Okay, so I think I'm audible. Okay, so we will solve this particular problem. Yesterday got stuck in alien dictionary, but our approach was correct. So then I have figured out that how to approach this particular problem. This was alien dictionary. So I was missing this base condition, and other than that, our code was almost correct. So wait a second. So today we will solve the last problem, advanced graph part. Okay, so the problem says there are n cities connected by some number of flights. You are given an array flights where flight I is equals to from to indicates that there is a flight from city from to city to with cost price. You are also given three integer source, destination, and variable k. Return the cheapest price from source to destination with at most k stops. Okay, if there is no such route, return -1. Okay, so we have to find the path from source to destination uh, with the cheapest price. Okay, so let's see an example. So here we are given n is equals to 4, means we have 4 nodes. Flight means we have a flight between 0 to 100. Similarly, so these are flight and 100 is their price, means from going 0 to 1 the price we have to pay is 100, and similarly for other nodes. So now what we need to, and we are given k as 1. So let's, here output is 700, so let's see why it's 700. The graph shown above the optimal path with at most one stop. So K is basically 1, so at most one stop from city 0 to 3 is marked in red. Okay, so this path is marked in red where we have one stop, means from source 0 to destination 3 we have this path, and it's this path having at most one node in between. Okay, so note that the path through cities, this path 0 1 2 3 is smaller, but it includes two stops. This is one stop and this is second stop. So this path is basically does not fulfill our condition that our path should contain at most k stops, means stops should be smaller than or equal to k. Okay, so the constraints are we have 100 nodes, and the flight's length is n square, basically means node edge from one node to other nodes are possible, means to all nodes are possible from two conditions. Price is this, from is not equal to 2, source and destination. Okay, source is not equal to destination. Okay, so what we can do, suppose we can start a DFS from here, and uh, in that DFS we can take care the depth of our DFS, means depth of our DFS should not be greater than k, means we can check, put a constraint on k, and we can try every path to destination from source. Okay, of means, and we will consider on paths which are means within k depth, and we can take a maximum of that path sum. Okay, so that would take means we have n nodes in total, and we are going to k depth. So that will be n raised to the power k solution. Means that will take this much time, means exponential time. Okay. So can't we do something like we can use a priority queue? Means we can start from here and we can put in that priority queue based on the cost, current cost. Suppose from this particular node, if we go to other nodes, we will increment the account variable means k, the depth, and we can add this to our queue, priority queue, and then we can choose the minimum path, and after that we will put other nodes as well. We can put other nodes as well. Okay, means it's something like it means dicastra, means we can modify dicastra, and it will also work in linear time complexity. So let's implement that approach. Means what we can do, we can maintain we can make a priority queue and maintain the depth of means current. Okay, let me see if I'm audible or not. Okay, so we have a number of nodes and these are our flights. So first we will create a graph, integer list of integer, foreign FLIGHT current flight in flights FLIGHTS in flights. Okay, so we will have a means this our from location will be FLIGHT flight of 0 and our to location will be this one. So we have from and to location, and we have also have a cost going from location to location. We also have a cost, so that will be a flight of 2. Okay, so now from this node we can go to this node, and having this distance we have means from this node we have an edge to this node having this much weight. So we need to put it in a map, so we need a map of pair. So how we can define our pair? So int to position and cost. Pair, wait a second, this to 2. Okay, so this is our pair class. Hi. So what we can do, we can put into our graph means compute if absent. So we can put flight from this position, and if nothing is present in our graph against this from against this key, we will put a empty. Okay, we already have. We will put a, so this syntax will put a new array list dot add. So at this position we will add a pair, means this will give us a list at this position. If list is not present, it will give us an empty list, and we will put a to and cost. So this is our directed graph. Okay, so you have 44 subscribers. What you do, bro? So we will create a graph. Sorry, we will take a priority queue to implement Dicastra. So priority queue. Hello. Okay, so we are starting from our source node. So currently we are having a depth of 0. So we have put it in our priority queue. So what we will do, we will sort our priority queue based on, sorry, we can't take a pair. We need to take something like this, means pair, because we are using for the map part. Okay, but we can also use a pair, as finally it's a pair, but our this variables can be confusing. So we will instead take a array of this size 2. So we don't have to mention the size here, and in that array we will sort the array based on the we will sort this our priority queue, means on the basis of the weight, means minimum. Okay, not weight, uh, on the basis of, okay, we also need weight and we also need k, means we need to sort it based on the k, then on the based on the weight. Okay, we need three things like suppose this is my comparator. Suppose what we can do, we can put 2 here, weight here, this is current weight, and k here. So first we need to sort it based on the k. We will prefer the shortest path first. No, we will prioritize cost, and along with cost we can don't con- we did not, we can't consider, or we cannot consider, we will not consider k. Okay, so what we can do, we can sort it based on weight, that minimum weight first. Okay, and we can add new int. To position will be source. Initially we are on the source. From source to source we need 0 weight, and k will be 0 initially. Okay, and while the size of our priority queue is greater than 0, we will continue our loop. And we also need a visited array, that the number of nodes we have visited. And what we will do, we will poll our current node from the current stop from the priority queue pq.poll. So our this current stop will be uh, let's call this node. Stop will be this, weight will be this, and k will be let's call something other, something different to k. Call the, so we have this station, and stops will be, what will be stops here, it will be node of 2. Okay, so we have this station, weight, and stops. So we need so So initially we start with this zero stop. Okay, and after that we go on to the neighbor of this station. We find its neighbor station. So this will be neighbor station. From graph we can get the neighbor station of this current station. And we will put, so this is our current stops we have taken. So initially we have taken zero stops. So once we reach this position, we will add a plus one to our stops. Okay, like we can put into our priority queue the neighbor to which we are going, and the current weight which we have plus the weight of the neighbor. Okay, and we need to put stops, so we will increment our stops also. So we will do stops plus one. Okay, once we reach here we will add a one. We our stop will be one. Once we reach here our stop will be two, but we want here our stop to be one because we have one stop in between. So we can start our k from minus one, and we can check if our stops are greater than k, means we can continue that we only process the values which are having stops in between smaller than or equal to k. Means we start from this node and we put initially minus one stops. Okay, that we haven't taken any stop from this position. Then we go to this position. So now also we don't have any stop in between. So now here my stop will be zero. After I reach this, and when I put 3 into my priority queue, then my stops will be 0 plus 1 1. So here when I reach here, so I have a one stop. Okay, so we will check that if we haven't reached stop greater than k. Otherwise stops will be smaller than equal to k. So we, what we can do, we can check. Let's say we have our current answer as 0, which we will be returning at the end. This means our stops are smaller than 1. We can check if our this station is equal to our destination uh, destination station. Then what we can do, we can update our answer as max dot minimum of our current answer. Let's take this as the maximum value possible. So this is the maximum possible value. Integer PQ node is this. Stops are greater than K. Minimum of the current weight. And we can further process. Okay, can we further process? Okay, I think we can directly return our answer from here. Means directly return W from here. And we can what two things we can do is first is we can check if our this current station is already visited, then we can continue. So we have these two things. Okay. And then we can mark visited as true for this station. And we will only put nodes which are not visited, neighbor which is not visited. So neighbor dot zero means this station should not be visited. Then we will only put into our priority queue. Let's see if this works. Okay, we have some issue. So one is this, we need semicolon here. Other is we need semicolon here. Are you from Ganpat College? Okay. What issue we are having with the priority queue? Priority queue A B. Okay. Wait a second. We can't do it like this, I think. Can we do it like this? Okay. And we can't fetch. Why we can't fetch? Okay, because our graph has pair. Okay. So we need a pair here, not this thing. And our pair have a two destination. Neighbor dot two, neighbor dot two, and neighbor dot cost. Okay, code is running, but output is not correct. So can we run dry? I think we should dry run for this part. Means for this particular graph. So what we are doing, our source is 0 and destination is 3. So we are putting source as 0 and destination, sorry, not destination, the current weight 0, and the current stops we are taking as -1 initially. So we are putting it into a priority queue and we are popping out it from our priority queue. Okay, this is our w weight stops. Okay, we check if it's visited current station. It's not visited, so we will mark it as visited, and we will check if our stops, okay, stops are greater than k. Okay, so the k here is 1, and stops now are here is -1, so this will also pass. Station is not equal to destination. Also, we will go to the neighbor of this station, means zeroth station. Suppose we don't have any neighbor. In that case, we will give an empty array list. Okay. So here we have one neighbor one. So we will put our that neighbor, and then we can put the current weight, which is 0 plus 100. Okay, stops will be 0 now. So now after popping our priority queue, we will have 1 with 100 weight and 0 stops. Okay, so we have reached 1. After this, we will see also this is not visited. We will mark it as visited true. Stops are 0, means not greater than 1. Okay, this is also not equal to destination. We will transverse the neighbors of 1. So neighbor of 1 are 3 and 2, and 3 and 2 are not visited also. So what we will do, we will put in our priority queue 3 with cost 100 plus 600. Okay, so after this stage, what we will be having, 3 with cost 700 and number of stops as 1. Okay, and also our priority queue will consist 2 with distance 200 and stops 1. So we will first pop out this because we are sorting our priority queue based on this particular index. So we will mark second station as visited. Okay, and our stops are 1. So our stop is not greater than k. Our source is also not, station is not equal to destination. We will now transverse neighbors of 2. So neighbors of 2 are 0. So 0 is already visited, and 3 is not visited. What we will put? We will put in our priority queue this pair, means 3. Okay, we need to put this condition above, because what we were doing here is we were marking 3 as visited, and we were continuing from there, and we never reached our this solution. So what we will do, if we see any condition, any node having stops greater than k, we will pop out it from the priority queue. So I think that's the thing we are missing. So I think now it should work. Okay, it's working. Okay. Let me see. We are getting output -1, expected is 6 for this particular case. So let's draw this 0 to 1 1 cost, 0 to 2 5 cost, 1 to 2 1 cost, 2 to 3. So k is 1, source is source is 0, destination is 3. Okay, destination is 3. We start from this particular, means first what we will do, we will add to our priority queue. Starting from 0, we will put 1 with distance 1 and number of stops 0, and we will put 2 with 5 uh, 5 distance and 0 stops. Okay, after we pop out this, what we will do, its neighbor is 2, we will put 2 distance and number of stops as 1. Okay, 0 marked as 0 as visited, mark this 1 as visited. Okay, now we are left with this two values in our priority queue. We will pop out the first one because it's having distance smaller. Okay, so we will visit its neighbor and we will put that neighbor, so its neighbor will be 3. So let me just put this here, means its neighbor is 3 with distance 6 and stops will be, okay, wait a second, we have two entries. First one is this with stops 1 and distance is 2. Okay, what we will do, we will put a node 3 with distance 3 having stops as 2 because 1 plus this stop, so we have added this, so this will be at the start. Okay, so we pop out this particular value and we see that our stops are greater and we do nothing, we pop out it. Then we process this value 250, and what we will do, okay, have we marked the 2 as visited? No, we haven't marked 2 as visited till we were getting -1 as the output. After we pop out this value, its stops are 0, means stops are not greater than k. Station is also not visited. We will mark the station as true. No, it's not equal to destination. We will put here 3, 6 and 1. Okay, and after that we We have popped out this value, so we will take this value out and our station will be this. Stops are not greater than k. Visited is also not visited, and we marked it as visited, and we return the weight 6. Okay, okay. What should we print here? How we can debug this? Source is this stops plus 1, pair neighbor. We can print priority queue after. Okay, but we can't directly print priority queue. It will just give us addresses. Okay, we need a iterator, means a entry in the priority queue to print. Without polling, we need to print. Okay, we can do this thing. Okay, and we also need a number of stops. Okay, we are having same two entries. in the priority queues. Let's print our priority queue here itself before polling anything. Okay, now we need a statement which can print to next line. Okay, so initially we have this in our priority queue. After that we are putting 1 1, okay, with 0 stops, which is correct. Then we are putting 2 5 0, okay, it's also correct. Then from 2 5, then from this value 1 1 0 we are putting 2 2 1, okay. So 2 2 1 means stops are 1 now, and 2 5 0, okay. So what we have done here is we have popped out this particular node, and we have passed this condition, and we marked it as visited, means we have marked 2 as visited, and we are putting this next value of the 3, okay. And after popping it this, our stops are becoming greater than k, so we are just not considering this, and we are considering this. So what we can do is, I think, uh, if our, let's say, stops plus 1 are greater than k, and our this station is not equal to destination, means if we are 1 away from the destination, means if we have used all our stops, okay, means till now we have used all our stops. It means stops are greater than this, and our station is not equal to destination, means we are supposed to reach our destination. If these stops are becoming k and we haven't reached our destination, then we cannot consider this current pair, okay. Okay, I need to draw this graph. 0 to 1, distance 5. 1 to 2, distance 5. 0 to 3, distance 2. 3 to 1, distance 2. 1 to 4, distance 1. 4 to 2, distance 1. Source 0, destination 2. And maximum number of stops are 2. Okay, from 0 to 2. So 2 to 5 and 9. 5 and 6. Okay. Mm, means we are failing at a condition where this stop is smaller than k. Mm, and we have reached the destination also. What if do something like this? Put the destination here. Integer dot max value. At the end, return answer. And answer will be minimum of current answer and w. And we can continue from here. Okay, means we are not marking destination as the visited. Let's see if this works for this failure. This is not working. Okay, still our output is 9. Means starting from 0, putting 3 and 1 with distance 5. Okay, then from this 3. Okay, our destination is 2. So from this 3, we are going to 1 with distance 4. Now we have 1 with distance 5. Okay, Okay, this approach will fail. We need some other approach. We need to see some hints. Means this approach will not work. Means along with me also need to maintain K. Means K. So means we are using correct algorithm, but we are having we are missing something. Means we are missing this test case. Means we don't have to mark our nodes as visited. We are marking them as visited. From 0 to 1. Okay, we need some modification. What we can do? When can we mark this as visited? If we are marking it based on the distance, then we are having greater stops. Can we prioritize number of stops? Means first we will take the smaller number of stops instead of distance. Okay. At the end, we need to return minimum distance of destination. Something like this. Can we use a distance array and relax the edges? Relaxing like Brother, the level of life always degrades. Means always workload. When workload never decreases, it keeps on increasing. So it's not like you grab a offer of 20 lakhs and you assume that there will be happiness in your life. It all depends on you. Life becomes very hectic. We have to go office from 9 to 6, 5 days a week. No, we don't get any time for upskilling. All depends on your company and team. If you are in a startup or in a company having not a good work culture, you will not get any time. You need some uh, means mental well-being time, so you will not get any time to upskill. And on Sundays and Saturdays you will not feel like doing something because you will be tired of doing 5 days work. कौन से कॉलेज में भाई तुम? ओके. जादवपुर यूनिवर्सिटी. ओके. In the case of distances, we will equal distances. We will prioritize by cost and by stops. Okay. Source on this. If stops are greater than k, we will continue. Otherwise, station equals to destination. This is our cost. New cost will be okay. Comparing this new cost with the current cost. Okay, I think I will do it tomorrow, not today. I am able to understand the approach, but I need more clarity over this. Means I want to implement it myself. So I will do it tomorrow. Means what mistake we were doing. We are having this. We are sorting based on this, not this, not the distance. Look, this is the thing which it is doing. Jodhpur University. Let's see the previous submission. Okay, so we'll solve it tomorrow using this approach only. Using Dicastra, we will see if its solution will exist or not. Otherwise, we will look for other solution. Okay.